We're always noticing new things that are happening.
Just a few years ago, satellite images showed Yellowstone's greatest rise in this area. Recently, however, it's reversed its direction and is now subsiding.
It's not actually within the Yellowstone caldera, yet it's one of the highest temperature thermal areas in the park. And it is possible that there is some magma extending to the north beneath that region.
The source of the basin's volatility could be magma, or another key component to volcanic activity, earthquakes.
The earthquakes are essentially the heartbeat of the system, are an integral part of the active, if you wish, mountain building and volcanism of Yellowstone.
Like smoke and fire, volcanoes and earthquakes go hand in hand. The pressure from the magma, which can explode into a volcano, also forces the ground to shift, causing earthquakes. They can be the telltale signs of an impending eruption.
The two main precursors to a volcanic eruption, seismicity and ground deformation, are very carefully monitored in Yellowstone.
In this computer model, each red dot represents an earthquake. Typically, hundreds of earthquakes are detected across the park each year. In recent years, the greatest earthquake activity has been centered under two areas of the park.
So you can see we have earthquakes that are concentrated on the north side of Yellowstone coming down through the park and then out extending on the east side of the Teton Fault right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could